Lesson number 38 is all about rectangular coordinates. And rectangular coordinates, well, whenever we solve a problem with rectangular coordinates, we're just going to be using a coordinate plane. So when we see this with our x going sideways horizontally, our y going up and down vertically, rectangular coordinates will be on a coordinate plane. Now, there's other words that you may see instead of a coordinate plane. You may see this. You may see a Cartesian coordinate system. Or you may also hear this. You may hear a rectangular coordinate system. They all mean the same thing. They all mean that we have our x going across and our y going up and down with our grid in between so that we can plot points. Now, whenever we plot points, we're always going to plot points with the x value first and the y value second. And we always put our coordinate pair inside of parentheses with x first and y second. Now, when we look at our coordinate plane, we have different quadrants. We have quadrant 1, which goes to quadrant 2, which then goes to quadrant 3, which then goes to quadrant 4, and back to quadrant 1. So you can see when we're naming our quadrants, and you do need to know the different names of the quadrants, we're moving in a counterclockwise direction. Please pause the video if you need more time to write this down before we move on to our next example. And as you write this down, if you were to just do it like this, your coordinate plane with quadrant 1, 2, 3, and 4, that would be good. And oftentimes you'll see them written with Roman numerals. So we could also have 1, 2, 3, and 4. But when you do copy this into your notes, you do not need to copy all the extra grid lines that we have that make it easy to graph points. Let's move on to our next example. 4 points are graphed on this rectangular coordinate system. What are the x and y coordinates of the points? So, let's go ahead and figure that out. We'll start with A. And for A, we're going to put them in a coordinate pair, and we're going to have x first and y second. It's always that way. X first, y second. So for A, on our x, we've gone over 1, 2, 3. That's how many we would need to get over to get to this position on the x-axis. So A is 3, and then for our y position, we've gone 1, 2, 3, 4. So we get 3, 4, because we've gone over 3, and then we've gone up 4 in order to get to that spot. Let's look at B. For problem B, well, we're going to go over, and we're going backwards this time, so it must be a negative number. And we've gone backwards, 1, 2, 3, 4. So B is going to be negative 4 for our x. And we go up 2 to get to this point. So it's going to be negative 4, 2. Problem C, well, you can see we've got to go backwards 3 from our origin of 0. So C is going to be negative 3, comma, and then we go down 1, 2. Whoa, C is way over here. I was looking at it this position. So let's back up. C is not negative 3. C must be, we'll get our pen tool again, C must be negative 2, because that's where we need to be to get to this dot. So C is negative 2 for our x, and then we go down 1, 2, 3, 4, and 5. So since we're going down, it must be a negative number. So negative 2, negative 5. And finally, D, we go over the same amount as we did for A, so 1, 2, and 3, and then down 2. So we're going to get 3 on the x, and then down 2, or negative 2, on the y. So we've got all of our values listed. Take your time as you work through these. Let's graph the following points. A is 4, 2. So we're going to go over 4, and we're going to go up 2. So there we have A. For B, we have 4, negative 3. X first, Y second. So we've got 4, 1, 2, 3, 4, and down 3, 1, 2, 3. So this is our point B. And then C is negative 4, negative 3. So negative 4, we're going to go backwards to the left, 2, 3, 4, so that's negative 4. Then we're going to go down 3 for negative 3, and we've got our answer for C. Let's move on to our next problem. Here we want to make a sketch of a rectangular coordinate system and graph the points, negative 3, 2, and 4, 1. So when you make a sketch of a rectangular coordinate system, all you need to do is make your X and your Y axes, and we'll redraw that one. And in fact, we're going to redraw the original one, because when we do these, we want a nice straight edge. So we're going to use our straight line tool. We've got our x-axis, we've got our y-axis, and then we've got our points in between. So the points in between, when we're sketching, we're going to make them as evenly spaced as possible. So first we have negative 3, 2. We've got negative 3 on the x, and 2 on the y. It's going to fall about right here. And then we have 4, negative 1. So 4 on the x, negative 1 on the y, will fall about right here. When we're asked to graph points, we only need to put the dots. There's no need to connect any lines. So we're all done with this question. Now one detail that we need to add is we need to make sure we have arrowheads on our x and our y axes, because they are lines. Let's look at our next problem. The vertices of a rectangle are negative 2, negative 3, 4, 2, 4, negative 3, and negative 2, 2. Draw the rectangle and find its perimeter. So negative 2, negative 3, negative 2, negative 3, that's going to fall right here. Then we have 4, 2, so 1, 2, 3, and 4, and up 2. 4, negative 3, well that's going to be 4, and then down 3, and negative 2, and 2. Now if we want to find the perimeter, well that's just a distance around the outside. So we can see going across, we're going to have 1, 2, 3, 4, 5, 6 units. So that must be the same for the top and the bottom. Going up and down, we must have 1, 2, 3, 4, 5 units. So that must be the same on both sides. So we get 5 plus 5, that's 10. Plus 6 plus 6, that's 12, which must give us 22. Now we don't know what the units are, but this is a distance, so we need to say 22 units. We need to have that label to get this problem correct. Lesson practice will be on page 125. Make sure you've got your notes complete, and I'll see you during our next class.